My name is Sean, and I'm a rising senior in high school, and I'm currently in the process of learning more about quantum computing and quantum algorithms through IBM's Qiskit programming framework. And as I learn about quantum and using Qiskit, I'm going to be creating videos documenting my learning process and explaining concepts that I'm learning along the way in a digestible fashion in order to improve my own learning and also help others who are interested in learning. So if you're interested in learning quantum computing, be sure to continue watching. I am by no means an expert on any of these topics, and I'm still learning, so be sure to let me know if there are any questions or anything I missed out on or could be improved. Thanks. Before we can understand quantum computing and why it's useful, we first have to understand classical computers and some of their pros and cons. Pretty much any type of computer that you use on a day-to-day basis is a classical computer, whether it's a smartwatch, phone, laptop, tablet, they're all classical computers. These computers work through the manipulation of data called bits. Bits are either a 1 or a 0, and they're always a single digit, and they can only be a 1 or a 0. They operate and change independently of one another. These bits have allowed us to do pretty much anything with classical computers, from watching Netflix to writing emails, playing video games, or creating art. They do, however, have some limitations. For example, when faced with extremely large and computationally demanding tasks such as factoring a very large number or some machine learning algorithms, they struggle pretty badly and can sometimes take literal years to finish these problems. This is where quantum computers become useful. Quantum computers replace the bit with qubits, or quantum bits. Very original, I know. Qubits, unlike classical bits, do not have to be in either a state of 1 or 0. Qubits can be in a state that is called a superposition, which means that the qubit is, instead of being in just one state or another, it has different probabilities of being in different states. The state is only definitively known when the qubit is measured or observed. It's quite a confusing concept that I had a lot of trouble grasping. A popular analogy used to explain the superposition is Schrodinger's cat thought experiment. Imagine there's a cat inside of a box with a bottle of poison. The cat's fate depends on whether it comes in contact with the poison. But until we observe inside the box, we cannot definitively say what state the cat is in, whether it's dead or alive. So we declare that it is both alive and dead at the same time. It's still a bit confusing, but as we look more into the math in some of it, superposition and what this means for qubits may become more comprehensible. I'll go into superposition in a bit more depth in a later video, but in short, this allows for the creation of algorithms that can be thousands of times faster than those implemented in classical computers with regular bits. To remain consistent with the previous examples, this can be used to break down really large numbers into their factors, which is a problem often used in cryptography, and solve those machine learning tasks that I had mentioned earlier with ease. While the technology is still in its early stages and mostly used for research, anyone can explore it through software like IBM's Qiskit. Okay, so for anyone interested in using Qiskit to kind of experiment with some quantum circuits, you can easily do so by going to a website called Google Colab. This allows you to run code in the cloud, which makes it very easy, and it's free for most use. And what you can do is you can copy and paste this setup code into a text cell. This works like a Jupyter notebook in Python if you've ever used something like that. So you can copy and paste this setup code in a cell. I'll provide it in the description if you'd like. And then once you run that, you can create some simple quantum circuits or whatever you'd like, just like this one here. So that's going to be it for this video. Thank you so much for watching, and be sure to come back for more. Thanks.